Welcome to today's deep dive. So, I want you to imagine you are in a high-tech hot air balloon. You're freezing in these bitter winds right over the desolate North Pole.
Right, just miles and miles of ice.
Exactly. You're expecting unbroken ice everywhere. But suddenly, you're peering over the edge of the basket and you find this open, liquid sea. And right in the middle of it sits a perfectly circular artificial island.
Which is just, mathematically impossible for nature to make.
Totally. And before you can even process the impossible geometry of what you're looking at, your balloon just stops falling down and it starts falling up.
Falling up, yeah.
You are trapped in this invisible vortex and you're just shooting away from the Earth straight into the stratosphere at these absolutely terrifying speeds.
And, you're experiencing this profound existential terror, not in some, modern cinematic blockbuster. This is a story conceived way back in the year 1897.
Wow, 1897.
Yeah. Decades before humanity even figured out how to fly a powered airplane, right? We're looking at an author who is dreaming up this scenario where gravity itself is a force that can be engineered, blocked, and even weaponized.
Okay, let's unpack this. We are diving into excerpts today from Kurd Laßwitz's late 19th century German science fiction novel. It's called Auf zwei Planeten, or On Two Planets.
Yep, a true classic.
And our mission for this deep dive is to explore how a writer from that specific era envisioned highly advanced alien technology. Plus, we're looking at a completely unique twist on the mechanics of first contact and some scientific concepts that were just surprisingly rigorous for their time.
Super rigorous, almost prophetic, really.
So we drop into the story on August 19th. That balloon I mentioned earlier, it's named the Pole. And inside, you have 3 human explorers.
Right, our intrepid trio.
Right. There's Torm. He's the seasoned, dedicated leader of the expedition. Then you have Grunthe, who is this incredibly stoic, strictly principled astronomer. And finally, Saltner, a highly energetic, very impulsive naturalist.
They really represent this fantastic cross-section of humanity to send into a first contact scenario, don't you think?
Oh, absolutely.
You have the authority figure, right? The avatar of pure logic, and then the embodiment of human curiosity. And they're all just crammed into this fragile basket drifting over the Arctic.
And at the time this was written, the poles were like the ultimate unknown frontier.
Oh, yeah. Expeditions back then were the equivalent of our space race.
Right. So finding an open sea and this island featuring a massive, intricately detailed map of the entire northern hemisphere carved right into its surface.
Just carved right in.
Yeah. It shatters their entire understanding of the natural world. The geometry alone screams that it isn't a natural formation.
No, it's way too perfect.
But they barely have a moment to register that someone or something built a giant map of their planet at the top of the world, because the balloon gets drawn to the direct center of the island.
Right over the exact mathematical pole of the Earth.
Exactly. And then begins the upward fall. They accelerate to a height of 20 kilometers in just a matter of minutes.
Which is incredibly fast.
Yeah, the atmosphere just thins out instantly. They are freezing, gasping for oxygen, totally at the mercy of this weird force.
Yeah.
To help you visualize this phenomenon, imagine dropping a magnet down into a metal tube, but just as it falls, someone flips the polarity.
Oh, that's a good way to look at it.
And that magnet just shoots violently straight up into the sky. But I have to ask, how does a writer in 1897 explain a balloon falling up?
Well, that analogy you use gets right to the heart of what the author called an aberic field.
An aberic field.
Right. Laßwitz treats gravity not as this absolute inescapable rule of the cosmos, but as a manipulable wave.
Okay, waves.
Yeah, so the center of this island is projecting a localized cylinder of zero gravity, which then shifts into reversed gravity. He theorized gravity as a wave moving at 300 billion kilometers per second.
Wait, 300 billion, that's specific.
Very specific. So the builders of this island are essentially catching the balloon in an invisible tractor beam.
Wow. I look at it almost like wearing noise-canceling headphones, but for gravity.
Oh, yeah, exactly.
Like the ambient sound waves, or in this case, the gravity waves, they're still hitting you, but the technology neutralizes their ability to physically affect you.
That's a perfect way to describe it.
Which forces us to ask why this invisible elevator shaft exists in the first place. Because, spoiler alert, this island wasn't built by humans.
Definitely not human.
It serves as a base for Martians. a highly advanced species who call themselves the Nume.
And what's fascinating here is the sheer engineering scale the Martians have deployed.
Yeah.
We're talking massive infrastructure.
Like planetary scale.
Exactly. Exactly. 6,356 kilometers above the North Pole, which, by the way, translates to precisely 1 Earth radius, there is a free-floating ring station.
Just hovering there.
Just hovering. It is held perfectly in place by a massive electromagnetic field generated from the island below. And the whole thing is powered entirely by collected solar energy.
In an 1897 novel, that's wild.
I know, right? And that aberric field we just described, it basically acts as a transit corridor. It's a cylinder of manipulated gravity used to ferry ships up and down between the earthbound island and this orbital ring station.
Okay, so it's quite literally a space elevator.
Yes, a gravity-powered space elevator. And the Martians pull this off by treating matter in a completely novel way. They can manipulate gravity by making materials what they call diabaric.
Diabaric.
Right, meaning the materials become completely transparent to gravity waves. Gravity just passes right through the hull of a ship without pulling on it.
Here's where it gets really interesting, though. The mechanics of that system create a terrifying crisis for our human explorers.
Oh, a massive crisis.
Yeah, because the Martians on the island realize these fragile Earthlings are caught in the transit beam. And if the balloon keeps shooting up this anti-gravity elevator shaft, they will just be launched into deep space and suffocate.
Which would be a terrible first contact.
A very short one, yeah. So the only way to save them from flying into the void is to quickly turn the anti-gravity field completely off.
Which, instantly reinstates standard Earth gravity.
Right.
So the balloon it collapses under its own weight and plummets back toward the surface, crashing violently into the icy polar sea.
Mm-hmm.
You have this violent collision of fragile human exploration and immense planet-scale gravity engineering.
It's just a brutal sequence.
The humans stumble blindly into this delicate infrastructure, and the emergency stop protocol nearly kills them all.
Yeah. Torm, the leader of the expedition, he's actually lost entirely in the chaotic crash.
Right.
But our stoic astronomer, Grunthe, and the energetic naturalist, Saltner, they survive the impact. And the beings who pulled them from the freezing water aren't exactly what you'd expect.
No, not at all.
The Martians come out wearing these weightless, gravity-manipulating diving helmets to fish the humans out.
Which is such a cool visual.
So cool. So they survive this massive, catastrophic event. But what kind of beings build something like this? When Saltner and Grunthe finally wake up inside the Martian base, the reality of Martian biology and culture is just completely disorienting.
Yeah, we get an incredibly detailed look at their physiological adaptations.
Tell us about that.
Well, Saltner wakes up to a Martian woman named C, while Grunthe interacts with another named Laß. Laßwitz details how the Martians have these unusually large eyes.
Like the classic alien look.
Kind of, but with a reason. They evolved to rapidly adapt to extreme light variations on Mars. They also have light-colored hair, and their baseline body temperature runs significantly higher than ours.
Because they come from a colder planet.
Exactly. A planet with a thinner atmosphere and a much harsher environment. So their bodies and their technology are deeply intertwined. For instance, they wear this beautiful metallic clothing that doubles as a flexible, unterrible armor.
And the daily technology they surround themselves with is like a dream for anyone who hates chores.
Oh, absolutely.
I mean, imagine waking up to a world of absolute frictionless automation. Saltner tosses his clothes in the air, and rather than hitting the floor, they automatically fly into a magnetic self-cleaning closet.
I could definitely use one of those.
Right. And when it's time to eat, there is no kitchen preparation at all. They have these push-button dispensing systems that provide perfectly nutritious, meat-filled pastry tubes.
Meat tubes.
Meat tubes. Plus, they communicate using a form of telephone that transmits complex information via light beams.
Which is essentially fiber optics.
Yeah, but I have to pause on their eating habits for a second.
Okay.
Because the Martians dispense a nutrient tube and then they eat it in total isolation.
Right, they hide away.
Yeah, they view eating as a gross, strictly physical act that just shouldn't be witnessed by anyone else. And I really struggle with this part.
Why is that?
Because breaking bread is a fundamental biological imperative, and it's tied directly to human empathy and connection, you know? Like, if you strip the social aspect away from dining, aren't you robbing a culture of its humanity? You reduce living beings to machines just taking on fuel?
Well, I mean, that interpretation makes a lot of sense from an Earth-centric viewpoint where food has always been a communal anchor for us.
Sure.
But consider the Martian environment and their evolutionary trajectory. They come from an older, likely resource-depleted planet. Biological functions, like consuming calories, probably became a source of severe conflict or desperation long, long ago in their history.
Oh, like fighting over scarce food.
Exactly.
Yeah.
So to survive and advance, they engineered their culture to treat food with absolute clinical detachment. They haven't lost their capacity for empathy or connection, though.
They haven't.
No, they've simply decoupled it from biological consumption. For the Martians, socializing is a purely intellectual and aesthetic pursuit.
Okay, that makes sense. And that brings up how they actually connect with one another, which may be the strangest detail in the entire base.
Oh, the pics.
Yes. When they sit down to have a conversation, they use these tools called picks. These are small wands that they literally tap against their foreheads while they talk.
Yeah, the pics deliver mild, pleasurable electrical currents directly to the nervous system.
That sounds intense.
A little bit, but the technology actively soothes them. It enhances focus, receptivity, and empathy during a dialogue.
Wow.
So instead of bonding over the shared sensory experience of a meal, they were bonding over shared, harmonized neural states. They were literally syncing their brain waves to foster better communication.
They are hacking their own nervous systems for better conversation. That is incredibly advanced.
It really is.
But this highly intellectual, neurosynced culture runs into a massive roadblock when dealing with the humans, the language barrier.
Right, because the Martians speak a highly logical universal language originating from a region on Mars they call Lockyer Land.
Lockyer Land, yeah. And you would expect a long, tedious process of the humans pointing at objects and grunting to learn the vocabulary.
That's the usual trope.
Right. But instead, the author introduces a massive paradigm shift. Grunthe is digging through their crashed luggage, and he discovers a German-Martian dictionary.
Which completely reframes the entire narrative.
It's mind-blowing.
I mean, this isn't just a convenient plot device. It implies a secret, pre-existing history.
A dictionary. Secretly packed in their gear by the expedition's financial backer, this man named Friedrich L. Just think about the geopolitical implications of that.
They're huge.
How on earth did L know the Nume existed? How did he acquire their language? Was there a secret prior contact?
Right. Or is L part of a breakaway faction of Martian living on Earth?
Exactly. The text leaves you reeling with the realization that this first contact might only be a first for the explorers, not for humanity itself.
And, the presence of the dictionary definitely accelerates their ability to communicate. But intellectual parity isn't what ultimately shifts the power dynamic between the two species.
No, it's not.
What really exposes the vulnerability of the Martians is biology, specifically the physics of our planet.
This is perhaps the most profound takeaway from the entire deep dive for me.
Oh.
The Martians are supreme intellects. They have orbital ring stations, gravity elevators, automated mansions, and neural syncing conversation wands.
But they have one glaring, near-fatal weakness on Earth.
The gravity here is roughly 3 times stronger than the gravity on Mars.
Yeah, they are literally physically crushed by our planet.
Just by standing there.
Yes. The atmosphere is thick and the gravitational pull is relentless for them. They can only walk upright indoors, where they have vast machines actively manipulating and lowering the local gravity to mimic the conditions of Mars.
Right.
But outside, on the actual surface of the Arctic, without technological assistance, they are effectively immobilized.
I try to picture it like if you've ever felt completely drained and heavy after a long-haul flight or experienced the G-force of a roller coaster.
Oh yeah, that heavy chest feeling.
Imagine feeling that intensely, constantly, just by existing. Earth is essentially a high-G centrifuge for them.
That's a great comparison.
To you, taking a few steps is nothing. To them, simply walking out the front door requires an armored exoskeleton and active gravity negation.
That's a huge effort.
And this physical vulnerability comes to a head in this brilliant scene. La, the Martian woman that Grunthe interacts with, goes outside onto the glacier wearing her specialized weight-reducing diving helmet. But she slips and she falls into an ice crevasse.
And during the fall, her helmet breaks.
Yes.
So in an instant, the technological buffer is gone. She is subjected to the full crushing force of Earth's natural gravity.
Which is 3G for her.
Right. She's completely helpless at the bottom of this crevasse, unable to muster the physical strength to even lift her own arms to save herself.
And who goes down into the ice to save her? Saltner. The human.
The primitive human.
The supposedly primitive Earthling. He scales down the frozen walls, and using nothing but pure human muscle, adrenaline, and an ice pick, he pulls her out of the crevasse.
It's an amazing scene.
There is something profoundly poetic about that moment. All of her civilization's advanced technology completely failed, and his raw evolutionary biology succeeded. It shows that technology has a hard limit when it meets the sheer brutality of nature.
If we connect this to the bigger picture, it radically balances the traditional first contact dynamic.
How so?
Well, in so much science fiction, when an advanced alien species arrives, humans are immediately relegated to the status of helpless pets or obsolete pests.
Oh, for sure. War of the Worlds style.
Exactly. The technological gap is just too wide. But here, Earth's sheer physical hostility makes human resilience and muscular strength incredibly valuable.
We have something they need.
Yes. The humans possess a biological currency that the Martians desperately need if they ever want to operate outside their carefully controlled environments. It transforms a story about inevitable alien supremacy into a nuanced exploration of mutual dependence.
It really makes you wonder who the fragile species actually is.
Definitely.
But as much as I love this earthbound survival element, we have to look at the macrocosmos. I mean, if the Martians are this physically delicate, how did they cross millions of miles of depth space to get here in the first place?
That's the big question.
Yeah, and the narrative eventually shifts back to the physics of the universe when the Martian captain, Joe, sits down to explain interplanetary travel to the humans.
Joe provides this fascinating history lesson that outlines their technological evolution.
What did they start with?
He explains that early Martian space travel relied solely on the gravity manipulation we discussed earlier.
The diabaric stuff.
Right. They would make a ship diabaric transparent to gravity and essentially just drift along the gravitational currents of the solar system.
Just drifting. That sounds...
Very slow.
Yeah, drifting on gravity means you are entirely at the mercy of orbital mechanics. It was incredibly slow, inefficient, and highly dangerous.
Okay, so to solve that, Captain Joe explains they developed a propulsion system called space, or directional shots.
Right, space.
They maneuver their massive ships by firing projectiles made of a highly condensed, volatile substance they call repulsate.
Repulsate, which is essentially condensed ether.
Right. And by firing these projectiles, they achieve speeds of 1,000 kilometers per second, cutting the Earth-Mars transit time down to just a few days.
Which is a huge upgrade.
It is. But I have to step into the shoes of our skeptical astronomer Grunthe for a moment, because the math here feels fundamentally broken to me.
Oh, the mass velocity issue.
Yeah, if you are commanding a massive spaceship, let's say it weighs 1,000,000 kilograms, and you fire a tiny 100-kilogram projectile out the back in order to propel that massive ship at 1,000 kilometers a second.
That projectile has to be moving fast. Impossibly fast. To generate the required specific impulse, we are talking about mass velocity ratios that just absolutely break the limits of classical mechanics.
This raises an important question, and your skepticism is entirely warranted under classical physics. But Laßwitz actually anticipates it within the text.
He does.
Yeah, Joe admits that to move a ship of that mass at that speed, the exhaust projectile would have to be ejected at 10,000 kilometers per second.
Okay, that's absurdly fast.
It is. But Joe doesn't stop at 10,000. He reveals that the ultimate theoretical goal of Martian physics is to achieve speeds of 500,000 kilometers per second.
Wait a minute, 500,000 kilometers per second.
Yes.
But the speed of light is only about 300,000 kilometers per second.
Exactly. Which means they are aiming for significantly faster than the speed of light.
How does an author in 1897 justify bridging the gap between a conventional rocket and faster-than-light travel?
By moving away from chemical combustion entirely, they aren't just burning fuel to push the ship forward like a modern rocket. Joe explains that they achieve this by literally exploding the cosmic ether itself.
Exploding the ether.
Yeah, Laßwitz is envisioning the sudden release of immense subatomic tension. Think of it like a coiled spring at a quantum level.
Wow.
By shattering the ether, they create a localized, catastrophic shockwave in the fabric of space.
So they're riding a shockwave.
Right, propelling the ship forward on a wave of pure physical distortion. And keep in mind, this was written decades before Einstein's theory of relativity formalized the absolute speed limit of light.
That is just staggering.
The author is playing with concepts of mass, energy, and the medium of space in a way that pushes the theoretical physics of the late 19th century to its absolute limits.
It is brilliant world building. I mean, he builds this complex physical universe complete with its own mechanics and limitations without ever losing sight of the characters experiencing it.
The human element is always there.
Always. And I think the reason this deep dive into zwei Planeten matters so much today is that it gives us this breathtaking look at concepts we are still grappling with.
Definitely.
It explores the extreme ends of gravity manipulation, the isolating cultural impacts of total automation, and that unforgettable human-alien dynamic where Earth's brutal gravity isn't just a natural phenomenon, it is our greatest planetary defense.
It forces us to recognize that our adaptation to our harsh environment is a profound strength.
Yeah.
The more technologically advanced a species becomes, the more fragile they are when removed from their tailored ecosystem.
We started today by talking about gravity as an inescapable law that just pulls everything down, but Laßwitz imagined a universe where that one-way street becomes the very highway we use to explore the stars.
It's a beautiful thought.
It really is. But before we wrap up, I want to leave you with one final mind-bending thought experiment introduced by Captain Joe regarding that faster-than-light travel.
Oh, this is my favorite part.
It's so good. Joe theorizes that if a ship travels faster than light, it outraces the light reflecting off the planets.
Because you're moving faster than the image itself.
Right. Which means if you could travel faster than light, turn your ship around and look back through a powerful telescope,
You'd see the past.
you could watch the actual history of Earth playing out in real time. The light from the past would finally be catching up to your lens.
It's basically a time machine telescope.
Exactly. So think about that. If you were sitting in that ship, outracing time itself with a telescope pointed back at our blue planet, what exact moment in the past would you try to witness?